Hello and welcome. In this video, we're going to take a look at how to work with tables in Matlab. This is going to be a very specific video that focuses on how to set up a results table that is the results of scanning multiple subnets of IP addresses and capturing or setting up the process of capturing then the results of that scan. The idea is that you would scan perhaps the 192.168.1.x network, followed up by the 192.168.2.x network. And ultimately, you want to put together a nice table of results showing, for instance, what machines responded and which machines did not. So the first thing that we want to do is take just a second to look at the help. I've went ahead and pulled up the help for the Matlab tables. Encourage you to pull it up and to possibly even go so far as to bookmark it. You can also work with the interactive help. You'll see that there's a number of functions that we can play around with. And specifically, we're going to be focusing in on the table constructor. We're going to be doing it one way. We're going to assume that we're going to be building this table from scratch, which is going to involve a little bit of setup. Another option is that you could also import it from a file and then work from there. But to begin with, let's understand the problem. So the first thing is that we want to be able to scan IP addresses from 192.168.1.0 technically all the way up to 192.168.1.255. And then we want to turn around and we want to repeat the process then for 192.168.2.0 all the way up to 192.168.2.255. Now, the idea behind this is that I may not necessarily know the range of IP addresses I wish to scan or even the specific IP addresses I wish to scan up front. So I have to be able to grow the table. Just like in the earlier video that focused on the cell arrays, the problem that we're going to run into is we don't know the actual size of the table until we actually run through the list of IP addresses. Now, in this particular case, we could actually kind of figure it out based on the length of each one of the subnets. But I'm going to give you a more generic approach that allows for us to add rows in the table as we go along. Now, with tables, tables in Matlab are current new addition to Matlab, relatively new addition to Matlab. So some of the features of the tables are evolving, and so you're likely going to find multiple different ways to go about doing this. I'm going to focus on maybe one of the most primitive or one of the most simple ways to go about doing it, and that is what we're going to do is we're going to set up a 0-row 4-column table. Now, why 0 rows and 4 columns? Well, it matches my earlier example from the cell arrays, but it also shows you then how to start a table from scratch. And in order to be able to start a table from scratch, you have to specify the column names as well as the column data type. And that is a little bit different from the cell arrays. So to begin with, what we want to do is we want to identify what we want to name each of our columns. And so in this particular example, I'm actually going to start working with strings. You don't have to necessarily work with strings. It just makes it a little bit easier because a lot of the functions leveraging tables also use strings, although they also seem to support character arrays in many examples. But we want to come up with then the names for each one of the columns, and I need to pluralize that. So the names, the first column I want to simply have as the ipv4 address. In other words, whatever we are building, whatever we're trying to capture, again, very similar to the example that we have with the cell arrays. The second column is going to be the command. In other words, whatever system command that we wish to ultimately run. The third column is just simply going to be the command out, the results of running the system command. I'm not going to be doing that in this video. I'm going to leave that for another video. And then the last column, or the fourth column, then is going to be the timestamp. Now, again, notice that each one of these are actually in double quotes because I'm going to be using strings here. Very subtle difference as opposed to the character vectors. The second thing that we need to do is we need to identify the types for each of these columns. And so for the ipv4, I am again going to go ahead and use a string. In other words, I'm specifying that the IP address is going to be stored as a string. The command is going to also be stored as a string. And then the command out likewise is going to be stored as a string. And then the last one is going to be stored as a date time. Now, again, I'm going to do this one a little bit different from the cell arrays example, just so that we get a little bit of variety here. You could technically also do all of these columns as character vectors, including the date time. You just have to be responsible then for converting the data types. Again, not a big problem, but we just want to see then a little bit of variety in this. The last thing that we need to do in this initialization or this creation of our table is going to be, of course, to assign it to a variable, but we'll call then our table constructor. In our table constructor, if we pull up the help real quick, there's quite a few overloads, and it arguably can get a little confusing. But the idea here is that we want to be able to specify the name value pairs. And so that's going to be the route that we're going to go. Most of the other examples focus on creating tables with existing data or possibly creating a table using columns. This one's probably going to be the easiest for us to understand. And the idea is that we're going to actually pass then a name value pair where we can look then at the variable names. We can specify then what we wish to pass, the data type that we wish to pass, and then so on. And so there's a couple of different ways that we can go about doing this. Again, what we're going to do is we're going to focus on what I feel is one of the simplest or one of the most straightforward ways to go about doing it. And what we want to do is we want to specify then the size of the table that I wish to create. I'm going to go ahead and move this out of my way here so that we don't lose any precious screen space. I'm also going to specify then the actual size of the initial table. Now, this is not the final size of the table, but I want to have 0 rows and 4 columns. The idea is I want to be able to add then the rows as I go along. In other words, as I loop through the IP addresses. Then the second parameter then we need to pass is going to be the variable types. And that means the data type of each of the columns. And you can see here that I'm basically storing these in my types variable. Do you need these do you need the names and the types variables? Absolutely not. You could technically put this all in one big long line. But again, for readability, I'm going to use the names and the types variables. And then the last one that we need to provide then is going to be the variable names themselves. And we can, again, just simply leverage that names variable that I have created. Now, I'm going to go ahead and leave the semicolon off here intentionally, so we get a little bit of noise in the command window. And you can see that I'm getting a 0x4 empty table. And you can do this a number of different ways. You can simply look at the results down here in the command window. You can notice here that you can actually follow this up then by typing in the period and then hitting tab, and you can see that I can actually specify then each of the columns. Now, we'll see, I think to make this video a little bit simpler, I'm actually going to go ahead and change one thing real quick. I'm going to change this. I'm going to remove the space. I don't want to make this one too complicated for our first pass, and there's really no necessity in having a space there in the timestamp. So why don't we just go ahead and remove that? And you can see here then timestamp, it just simply becomes a field like the other one. So there's ipv4, the command out, and then the timestamp. In addition, you can actually look at the properties of the table, an individual row, and also the variables. But again, we're going to come back to some of this in later videos as we start using tables. Instead, what I want to do is I want to now focus on the process of looping through all of the IP addresses. So the idea here is I have my 4 octets. This is my 3rd octet that I'm going to essentially range from 1 to 2 or possibly further. And then my 4th octet that is going to go from 0 to 255. Again, we're assuming that we have some sort of variable input source for this IP address range that we ultimately need to scan. And so initially then we're going to leverage a nested for loop. And I'm going to start off then with a variable that I'm just going to call octet3, which is going to loop from 1 to 2 or 1:1:2, and for that outer for loop, and then an inner for loop that allows for me to leverage then our 4th octet from 0, 1 to 255. And again, this is just setting up our nested for loop that we are ultimately going to use to create then our ipv4 address. Now, in this video, I'm going to do this a little bit different. I'm actually going to use my sprintf function, but I'm going to use it with strings, not with character vectors. And so if you take a look at the help for sprintf, you'll notice that it has a little bit of a dual modality, if you would. And the idea here is that you can return either a string if it is past a string, or a character vector if it is past a character vector. And so again, to fully embrace the strings, my intention here is that I'm going to pass to it my 192.168 dot and then %d dot %d. But this time around, I'm going to enclose it or encapsulate it in double quotes so that I return then a string. And then for that first placeholder, I'm going to pass my octet 3. And then for that second placeholder, I'm going to pass that octet 4. And just to inspire a little bit of confidence here, I'm going to simply display my ipv4. In other words, I just want a little bit of a sanity check to see if I'm on the right path. And again, if we run this real quick, we can simply see that I'm going to go ahead and put a semicolon on this line right here since I've got my display. Tell you what, I'm going to go ahead then real quick, and I'm going to clear my command window just so we don't get too much noise down here. And then you can see here that I am in fact looping through all of the IP addresses for both subnets. So far it looks pretty promising. You can optionally leave that display in if you would like to. Now what I'd like to do is I'd like to go on and go ahead and create the command that otherwise or ultimately you're going to pass to the system command. And in that case, then you just need to be reminded of the fact that effectively what you would be doing is you would just simply be pinging an IP address. And so just as a quick reminder here, I'm going to pull up in my console and I'm going to ping, in this case, I'm just going to ping the local host once. But just so you can see the pattern here, then that we would expect to get some sort of reply, and that reply then we would hope to capture in the command out. Now, the idea here is that I want to replicate this pattern here. Again, I'm going to use sprintf, and I'm going to simply put this in as a string. So I'm going to do a ping-n space 1, and then follow that up with a %s, this time with that placeholder being filled with my ipv4 address. Now, at this point, we could go ahead and display this just to verify that we are, in fact, doing something right, or we can move on to the real topic of this video, and that is how do we ultimately then update this results table. And so the idea here is that we would want to put the ipv4 address, the command, and possibly even the command out, as well as maybe a timestamp in this results table. And to do that, then we simply specify the results. We look at the field that we wish to update, and then we specify then the row index. Well, that's where we run into a little bit of a problem. Because we have a nested for loop, we can't just rely on one of the loops to provide us with the index for our results table. Instead, what we want to do is we simply want to provide then another variable that we're just going to call row count. And row count will simply give us the size of the existing results. And specifically what we want to do is we want to focus on the size in the first dimension or the number of rows. And now as a quick sanity check, we can run this and we can see that, of course, initially we would have 0 rows in our table. And the idea is that each time this loop runs, then we would simply take this row count variable and we would add 1 to it to add another row in our table. Now, much like what we would do in the cell arrays example where we would specify the column, instead in the table, we specify the column name. So again, it's a little bit different, but the principle is the same in that we would assign then whatever value we're interested in assigning to the ipv4 column in our new row. And in this case, it's just going to be our ipv4 string variable. Now, if we continue on with this real quick, we may have a little bit to play around with. We may make some mistakes as we go along, but we're going to go ahead and add our command. And again, our row count +1, and then we will simply store in that the command variable, the output of that second sprintf. I'm not going to populate the command out. I'm just simply going to initialize it to something other than an empty value. And the way that we do this is then we simply set it to an empty set of double quotes. And then the last one that I want to look at then is if we look at our timestamp, and again, our row count +1. And in this case, we're going to do this a little bit differently. Instead of using the date string and now function, what I would like to do is I'm going to actually use date time. And if you come down here to the command window for just a second, you could see that it provides similar results to our date string now alternative. The big difference, of course, is that the data type is now a 1-by-1 date time. Now, let's see if we've got any mistakes here. Let's go ahead and run this. We'll highlight it and run it. We get a whole bunch of warnings. And the reason for it being is that we are continuously growing the table. In a perfect scenario, you would simply just go ahead and assign a value to the number of rows. But again, we didn't know necessarily how many we will have. And in this particular example, you can guess quickly that it's going to be 512 rows. However, though, if you did not have the luxury of that, perhaps you were reading in the IP addresses from another file, again, you'd have to figure out somehow the maximum number of rows that you would need in your table. And so you can see here that our results now are a 512 by 4 column table. And you can see that in each of the columns, I have the respective values that I'm interested in. And then ultimately, again, you would want to combine this with another function to be able to get our command out. But you can also see here that my timestamp is also being captured. In other words, we want to know when, for instance, we ran our ping scan. So hopefully you found this video useful. Hopefully this gives you a little insight on how you would create a table from scratch in Matlab. And again, this functionality for the tables is growing with each release. Hopefully they're going to improve some of these constructors and add some extra features. But if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.